In this lecture we will look at confidence intervals with two samples, and we'll start with averages. Just as we've looked at two sample averages with the estimation, that is the sampling distribution of x bar 1 minus x bar 2, set it on mu1 minus mu2. We'll do the same thing here, but we will now try to estimate the mean or middle of that distribution. And the mean of the distribution of averages is the difference in the two population means. So if we have a sample estimate that is a point estimate, the sample difference x bar 1 minus x bar 2, the population parameter that we're estimating parameter just means measure, is the difference in the two population means, mu1 minus mu2. And the sampling the central limit theorem holds here too. So if the samples are large enough, then the x bar 1 minus x bar 2 will be normally distributed around mu1 minus mu2. Alright, so for sufficiently large samples we get this approximate normal distribution. Alright, so this is the sampling distribution of these guys, x bar 1 minus x bar 2. The middle of this distribution is mu1 minus mu2. We have a true standard deviation also, but in this case what we're trying to do is to estimate where the middle of this distribution is, right? The mu1 minus mu2. Alright, so we have two groups or two samples, so we'll take group or sample number 1, and out there is a population mean mu1, which we don't know and may not care for. All we may care for is the difference, mu1 minus mu2. We'll need sample information, we'll need a sample size n1, a sample average x bar 1, and a sample standard deviation S1. And then for group or sample 2, again there'll be a population average mu2 out there. We'll need to calculate the confidence interval along with the above sample information. We'll need n2 sample size for the second one, x bar 2 the average for the second, and S2 the standard deviation for the second group or sample. Okay, so it's these two that we don't know. In actual fact, it's mu1 minus mu2 that we don't know, and we're trying to estimate. Okay, and to get an estimate we will take x bar 1 minus x bar 2. In nearly all problems, x bar 1 and x bar 2 will be given. Alright, but sometimes, rarely, instead of those two being given separately, you'll be given one number for the difference, x bar 1 minus x bar 2. Alright, let's have a look at a problem, and you'll see how simple these are. Right? These conform to the process of getting confidence intervals for one sample, but they have more information and more formulas. Before I go to look at a problem, let's just write up the general formula. Alright, so we have a confidence interval for the difference mu1 minus mu2. Alright, so this thing as a whole is equal to the sample difference x bar 1 minus x bar 2 plus or minus an appropriate z value times the standard deviation here, S with a subscript x bar 1 minus x bar 2, where S of x bar 1 minus x bar 2 is the square root of S1 squared on N1 plus S2 squared on N2. Okay, and beyond that we get the z values in the same way that we had the z values before, and all we have to do is, as I said, different formulas.